Hello everyone. So far in this video series, we talked about nitrogen processes in the shallow as well as in the deep zone, and how to set up these different reaction networks within the BioRT model. We also look at how the different reaction rate parameters could affect. We also looked at different reaction rate parameters. It is important to keep in mind that these parameter values can be altered during the calibration process so that your model nitrogen species can better match your measurement data for your specific catchment. It is a good practice to start with a manual calibration process to see how altering different parameter values could affect model results. So for this video, I'm going to do one practice example to see how altering a parameter value could affect model results as an indication of what a manual calibration process could look like. So let's continue with our denitrification process reaction network and looking at our specific reaction rate, our simplified reaction rate law. The associated terms that could be altered, which will directly affect our reaction rate and the concentration of nitrate as well as the N2 produced. Okay, so let's alter our A term corresponding to the our specific surface area in our CINI text file, saying that we believe our denitrification rate is too high and there should be more nitrate in the stream in comparison to the base case that we graphed in the previous video. We could decrease our SSA value in the lower zone, as well as all denitrification processes should be occurring within the lower zone from a value of 0.005 to something like 0.01. 0.001. We should anticipate that this should decrease our reaction rate, causing less nitrate to be used up in the denitrification process and less N2 to be produced. So let's do so. So here I have my input files for my denitrification processes. I'm going to open up my CINI file, which, as you can see, in comparison, we used to have a 0.05, 0.005, and which right now I have a 0.001. So I'm going to save this input file, and then we can run the BioRT simulation for it again. So I'm putting in my executable for my BioRT code and then denitrification. So once again, we see that the model ran successfully. And we're good. Like I said, like with the previous videos, I have already graphed the results. So we're just gonna jump right into to see what the alter outcome should look like. So let's compare our results to the base case scenario, starting with the nitrate concentration in the different zones with a plot from the base case on the left. So this is our base case. And then we have a new case on the right with the decrease in our SSA value. So the first thing to notice is on this y-axis, we see that there is an increase of our nitrate concentration, which then fits our prediction. There is also a clear increase in the nitrate concentrations coming in from the lower zone, to point out that during the even during the colder seasons, the amount of nitrate coming from the lower zone can be even greater than the nitrate discharge from the upper zone. The pattern of the stream nitrate, however, still follows closely with the upper zone nitrate patterns. And then if we do the same thing for N2, you can see here are the plots for the N2. Once again, we have the base case on the left and then our altered scenario on the right. And then if we look at it, we can see that the N2 concentrations do decrease, but there is no real change to the pattern of the N2 concentration. So with that, it completes our video series for the nitrogen processes using the BioRT-HBV model. Hopefully these videos were helpful and meaningful to you and help you have a better understanding of the model.